Welcome to today's lesson on energy within systems. Today, we will cover the following key topics. We will begin by exploring what a system is and how energy is stored in various forms within systems. Next, we will discuss open systems, using boiling water in an open saucepan as an example. Finally, we will examine closed systems, using a sealed thermos flask with hot coffee as our example. Understanding how energy is stored and transferred within systems is fundamental to physics. It helps us explain and predict how different systems behave and interact in the real world. A system in physics is an object or a group of objects that interact with each other. For example, a mug on a table can be described as a system. These systems can store energy in various forms known as energy stores. For example, a stretched rubber band has elastic potential energy, or a hot object has thermal energy. When a system undergoes a change, energy is transferred within it or to and from its surroundings. Consider a toy top spinning on a table. When you spin the top, you're giving it energy. This energy is stored as kinetic energy, a form of energy due to motion. The top keeps spinning because of this kinetic energy. However, as the top slows down, it loses this energy, transferring it to other forms such as sound energy, as it makes the buzzing noise as it slows, and thermal energy, which we can see in the slight warming of the air and the table. Systems can be classified into either open or closed. Let us start by exploring open systems first. Open systems are capable of exchanging both energy and matter with their surroundings. For example, boiling water in an open saucepan is an open system. In this scenario, the boiling water and the saucepan form the system. Heat energy from the stove transfers to the water, causing it to boil. The water vapor, or steam, escapes into the surroundings, transferring heat energy out of the system. Therefore, both energy and matter exit the system. Contrastingly, closed systems do not allow the exchange of energy or matter with their surroundings. Let us take a sealed thermos flask containing hot coffee as an example. Here, the thermos flask and the coffee form a closed system. The insulation provided by the thermos prevents heat energy from escaping, ensuring that the internal energy remains within. No matter enters or leaves the system, keeping it self-contained. The energy within the system changes only internally. When a system undergoes a change, energy can be transferred in several ways. First, energy can move from one part of the system to another. For example, in an open saucepan on the stove, heat energy is transferred from the hot pan to the water inside it. Both the pan and the water are part of the same system. Secondly, energy can change from one type to another within the system. For example, when heating water in a hot pan, the water will begin to make bubbling noises. In this case, heat energy changes into sound energy. We will develop our understanding of kinds of energy in future lessons. Finally, energy can be transferred into or out of the system, affecting the surroundings. For example, in the open saucepan, heat energy is not only transferred to the water, but also lost to the surrounding environment. For example, air and kitchen surfaces. Whether in an open or closed system, energy is always conserved, meaning it is not created or destroyed, but simply transferred into different forms or between objects. This is an important concept in physics that we will also explore this further in an upcoming lesson. Understanding the basic principles of energy systems that we have looked at today helps us to analyze more complex phenomena in physics, where energy transfer and storage play critical roles, from simple mechanical systems to intricate biological processes and advanced technological applications. In today's lesson, we focused on understanding how energy is stored within systems and how energy transfer occurs when a system changes. We identified that energy can be stored in various forms, such as thermal, kinetic, and sound energy. We defined a system as an object or a group of objects that can interact with one another, and we also learned about the distinction between open and closed systems. By understanding these concepts, we are better equipped to analyze how energy flows and transforms in different physical scenarios.
Watch the rest of the GCSE physics course at Sophos Education.